Good morning, friends. Now next, today we are starting the problems on the chapter 9. First problem. A tank is filled with water to a height of 12.5 centimeter and the apparent depth of a needle is lying at the bottom of the tank is measured by a microscope to be 9.4 centimeter. What is the refractive index of the water? If the water is replaced by a liquid of refractive index 1.63 up to the same height. Next, by what distance would the microscope have to be moved to focus on the needle again? Now let us consider here what they have given. Now just we are writing the given terms, that is the data. Now in the first one we are considering the actual depth of the needle in the water. Actual depth of the water in needle. Is equal to 12.5 centimeter. 12.5 centimeter. Next, in the same way, again they have taken that the apparent depth of the needle. Given that the apparent depth of the water in the needle is equal to, if they have given how much? 9.4 centimeter. 9.4 centimeter. First one we are considering the actual depth. Second one they have given the apparent weight. Next we have to find here refractive index. The value of the refractive index we have to find here, that is mu. Refractive index we are considering it as mu. Therefore the formula mu is equal to H1 by H2. And in this case, H1 we are considering the actual depth of the water in the needle. This is your H1 and this is H2. H2 means apparent weight of the water. Then according to the formula, mu is equal to H1 by H2. Put the values of H1 and H2. H1 is 12.5 divided by 9.4. Now when we are calculating, we are getting the answer as 1.33. This is the value of the mu, that is the refractive index. The value of the refractive index we are getting as 1.33. Or now next, water is replaced by a liquid of the refractive index. Now next what we are doing, water is replaced by a liquid in the refractive index. Now let us consider here, let y be the new apparent depth of the needle. Y we are considering as a new apparent depth. We have to consider y has the new apparent depth of the needle. Hence we can write the relation as mu1 is equal to H1 by y. Formula mu1 is equal to H1 by y, or this can be also written as y is equal to H dash by mu dash. Y is equal to H dash by mu dash, or H1 by, sorry, here it is H1. Now put the values of H1 and mu dash, and from that we can calculate the value of y. Therefore 12.5 H1, 12.5 divided by mu dash we are considering as 1.33, or they have given that if the water is replaced by liquid of the refractive index, they have given mu dash is equal to how much? 1.63. The value of mu dash is 1.63. Now next, the total calculation part, we are getting the answer as 7.67 centimeter. 1.67 this we can tell that here the new apparent depth of the needle is 7.67 centimeter. Now next we can tell also that it is always less than H2. We got the value H2 is equal to how much? 9.4 centimeter. It is always less than the H2 value. Therefore, to focus the needle again, the microscope should be moved up. Therefore, the distance by the microscope should be moved up by, here we are considering the distance of the microscope which has to be moved up is given by 9.4 minus 7.67 centimeter. Here the answer we are getting has 1.73 centimeter. 1.73 centimeter. This is when we are getting this much answer, when the distance of the microscope should be moved up. That time we are getting the difference of the HO2 minus the new apparent depth. That is equal to 1.73 centimeter. Here in the question, first we have taken the height. They have given how much? 12.5 centimeter H1. Next we are considering H2 is equal to how much? 9.4 centimeter. Here what we have to find? First we have to find the refractive index of the water. Here we have taken the formula mu is equal to H1 by H2. From this we are getting the refractive index. In the same way, if the water is replaced by a liquid, in the case of the water, we are considering the liquid. That time we are considering y is the new apparent term. Therefore, the formula mu dash is equal to H1 by 5. Just find the value of the y. Y is equal to, we have taken H1 by mu1. Mu1 is equal to, they have given the value. The refractive index should be, when the water is replaced by a liquid, the refractive index should be how much? 1.63. Put all the values, we can get the y is equal to 7.67 centimeter. Next question they have asked, by what distance should be the microscope have to be moved to focus on the needle? Again, what we are considering here, first we are considering the value of H2 and minus we are considering the y. That time we are getting the answer as 1.73 centimeter. This is the answer when the distance should be moved from the microscope, how to be moved to focus on the needle. How much we are considering? 1.73 centimeter. Now second one, a beam of the light converges at a point capital P. Now a lens is placed in the path of the convergent beam 12 centimeter from the P. At what point does the beam converge if the length is? First one, a convex length of the focal length 20 centimeter. Second one, a concave length of the focal length 16 centimeter. Now in this condition, first we are telling that in the given situation we are taking that the object is virtual and the image form is real. First we are considering object is virtual and image is real. Now when we are considering in this way, first one, a focal length of the convex lens f is equal to 20 centimeter. First one, a focal length of the convex lens, they have given how much? 20 centimeter. Now let us consider, or the image distance we are considering as b. Image distance we are considering b. Now here we got the value of the focal length of the convex lens is equal to 20 centimeter and the image distance we are considering as a b. Now according to the length formula, we can write the relation as 1 by b minus 1 by u is equal to 1 by f. Formula 1 by b minus 1 by u is equal to 1 by f. Just put the values 1 by b minus 1 by u. Here in the question, now a lens is placed in the path of the convergent beam. It is 12 centimeter. Okay, u is equal to, we are considering 12, is equal to 1 by f. The The value of the f is 20. Next, 1 by b is equal to 1 by 20 plus 1 by 12. 1 by b is equal to 1 by 20 plus 1 by 12. Now total answer we are getting here 3 plus 5 by 60. 8 by 60. Cancel the term, will get cancelled. The total answer we are getting here b is equal to 7.5 centimeter. Here we are getting the value of the 1 by b is equal to 8 by 60. When we are calculating b is equal to, we are getting the answer here 7.5 centimeter. Or this can be also written in the form of b is equal to 60 by 80. That time we are getting the answer b is equal to 7.5 centimeter. Here we can tell that the image is from 7.5 centimeter away from the lens. It is away from the lens. And it is always at the right side. It is away from the lens and it is always at the right side. In the same way, we have to find the second one. They have given that a concave length of the focal length f is equal to 16 centimeter and image distance is equal to v. Now next we have to calculate for the second one. Let us consider the formula. Again we are considering the v. 1 minus v minus 1 by u is equal to 1 by f. Put the value of u and f. Again here also we are considering the image distance should be v. Image distance is equal to v. Next 1 by v minus 1 by u. 1 by u means again minus 1 by 12 is equal to 1 by f. Here f is equal to, we are considering 20 centimeter. Now next again calculation part. 1 by v is equal to 1 by 20 plus 1 by 12. Now calculating the value, v is equal to, we are getting the answer as 48 centimeter. V is equal to 48 centimeter. V is equal to 48 centimeter. Here the image is formed at 48 centimeter away from the lens. Away from the lens, and it is also towards the right side. Therefore, first one we are getting the answer as 7.5 centimeter, that is away from the lens and it is also at the right side. Second we are getting v is equal to 48 centimeter, it is also away from the lens, we are getting the answer as the towards the right. Now next question. What is the focal length of a convex lens of the focal length 30 centimeter in contact with a concave lens of the focal length 20 centimeter? Is the system converging or diverging lens? Ignore if the thickness of the lens. Just we have to tell that either it is a converging or diverging lens, and if the thickness is there, we have to neglect the thickness of a lens. Now first we have to write the given term. According to this, they have given that the focal length of the convex lens, the focal length of a convex lens f1 is equal to 30 centimeter, and same way concave length of the focal length of a concave lens f2 is equal to 20 centimeter. Next question is either it is a converging or a diverging, we have to study here. Next we are writing here the focal length of a system of a lenses is equal to f. The focal length of a system of a lens is equal to F. Now next the formula we are considering has 1 by F is equal to 1 by F1 plus 1 by F2. Put the values of F1 and F2. 1 by F1 is 30 plus 1 by 20. 1 by F is equal to, we are getting this much. Next the total calculation part we are getting has 1 by F is equal to 2 minus 3 by 60, or it is equal to minus 1 by 0. Therefore the total value of 1 by F is equal to minus 1 by 60, or F is equal to, we are considering minus 60. F is equal to minus 60. Next, here the negative sign indicates that the system or the length act has a diverging length. Here we can tell that this F is equal to minus 60. If it is having the negative sign, we can tell that it is acting as a diverging length. Diverging